Dear students, today we are going to discuss some questions based on the chapter atoms. As you know, there are several models of atoms. The first accepted model may be the Rutherford model, and it was modified by Bohr, and the Bohr model is widely used or explained in this chapter. Okay, here we'll start with the first question. To explain his theory, Bohr used the principle of, as you know, Thomson model is having some plum pudding model, and then Rutherford model based on the alpha particle scattering by Geiger and Marsden. And the next model is Bohr model. By this model, he assumed certain postulates. The first postulate is that electrons will revolve in circular orbits which are non-radiating. As you know, if they radiate, they have to fall on the nucleus by releasing energy, since accelerated charges should radiate energy. And based on the three postulates of Bohr, first postulate is orbits are non-radiating. Second postulate is angular momentum is an integer multiple of h by 2 pi. Angular momentum is an integer multiple of h by 2 pi. Integer means n, 1, 2, 3, etc. n h by 2 pi. And by third postulate, emission or absorption of energy takes place only if electron jumps from one permitted orbit to another, obeying quantum conditions. E2 minus E1 equal to h nu. Here by the second postulate, angular momentum is an integer multiple of h by 2 pi. That is, there is quantization of angular momentum by Bohr model. The answer is option B. Now the second question. The size of atom is to be compared with the size of nucleus. As you know, the size of atom may be of the order of 10 raised to minus 10 meter, and the size of nucleus may be of the order of 10 raised to minus 15 meter. We have to compare the volume occupied by, not the size, so that the volume of atom may be like this, 4 by 3 pi r0 cube is the volume of atom. And the volume of nucleus, I may be taken as 4 by 3 pi r cube. That means it is r0 cube by r cube, that is 10 raised to minus 10 the whole cube, size of atom minus 10. And for nucleus it is 10 raised to minus 15. We will get 10 raised to minus 30 divided by 10 raised to minus 45 equal to 10 raised to 15. Hence, the correct answer is option D. The volume is 10 raised to 15 times. Find the distance of closest approach. When a 5 MeV proton approaches a gold nucleus, you may know by Rutherford's scattering experiment by Geiger and Marsden, when an alpha particle approaches the gold nucleus, as it approaches this positive charge approaches positive, it comes to rest for a moment so that its energy may be retained or converted to potential energy, so that this energy is equal to the potential energy, that is 1 by 4 pi epsilon 0 Q1 Q2 by R. Potential energy is given by E equals 1 by 4 pi epsilon 0 Q1 Q2 by R. The distance up to which it approaches, at which there is some potential energy, to retain it and then to return back. This energy is 5 MeV, mega electron volt. That means 10 raised to 6 eV. That means 10 raised to 6 into 1.6 into 10 raised to minus 9 joule. Or it is 1.6 into 10 power minus 3 joule. That's the energy. Here the energy is 5 MeV. That means E equals 5 into 1.6 into 10 raised to minus 13 joule. This much is the energy. Then we may substitute here 5 into 1.6 into 10 raised to minus 13, 5 MeV equals 1 by 4 pi epsilon 0, 9 into 10 raised to 9. Q1, a proton and Q2, a gold nucleus. A proton and a gold nucleus. Proton charge 1.6, 10 raised to minus 19. Gold nucleus is having Z 79, Q2 equals ZE 79 into 1.6 into 10 raised to minus 19. Like this, divided by R. We have to calculate this R. That is R equals 9 into 10 raised to 9 into 1.6 and power minus 19 into 79 1.6 10 raised to minus 19 divided by this much 5 into 1.6 into 10 raised to minus 13. On simplification we will get the correct answer becomes 2.3 into 10 power minus 14 meter. The correct answer is option B. It is 2.3 into 10 raised to minus 14 meter. Now the fourth question. When an electron moves from n equal to 4 to n equal to 2, the emitted spectrum, line spectrum will be, which one is the line spectrum? As you know, here it is n equal to 1, then n equal to 2, n equal to 3, n equal to 4, n equal to 5, like this the energy states. By falling to Lyman series, this is the first member of Lyman series, and this is the second member of Lyman series. These are called the Lyman series, and by falling to n equal to 2, now it is called the Balmer series. As you know, Balmer series is in visible region. This only is in visible region. This is Lyman series in UV region. Lyman series is in UV region. Balmer series is in visible region. And then these are Paschen, bracket fund, or others are in IR region. Here the question is, by falling from n equal to 4 to n equal to 2, any line falling to n equal to 2 is called Balmer series. Here the answer is to be by falling from n equal to 4 to n equal to 2, and this to be the second line of Balmer series. The answer is option B. Now question number 5. Which of the following spectral line falls within the visible range of electromagnetic spectrum? As I mentioned in the previous question, by falling from higher to first line gives Lyman series, and Lyman series is in UV region. By falling to second energy state, we'll get Balmer series. This alone is in visible region. By falling to third, we will get Paschen, then fourth to bracket, and fifth to fund, etc. They all are in infrared region. Hence, the only line in visible region is this is a Balmer series. Balmer series alone is in visible region. Okay, this is some chapter based on both chemistry and physics. Atom model is an important chapter. We can get a lot of questions based on this in physics and chemistry. We can work hard, and we may use certain equations, E2 minus E1 equal H nu, like that. From this, you can work a lot of questions, also some problems based on this chapter. Okay, work hard, try the best. Okay, best wishes. Thank you all.